So Lake Superior, for example, which is the deepest and the largest of the lakes, has a retention time of almost 200 years.
200 years?
Yeah, so any water that we're drinking today is almost 200 years old.
So if something gets into the water, like a pollutant, how long is that going to be with us?
It's the same thing. Anything that gets in today is going to be with us for another 200 years.
So pollution today is going to be around until 2208?
It's going to be around for a while.
So what are some of the pollutants we have to worry about?
Some of them are herbicides, for example, which kill the weeds and things in our lawn, or pesticides, which get rid of the bugs, heavy metals that we can find in electronics, or even the stuff that comes out of the tailpipe of our car.
Wow, so how do those things actually get into the Great Lakes?
There's a couple different ways, but the pollutants are generally pretty tough, hardy things that don't break apart and don't degrade very easily. So they get up into the atmosphere, and then they'll come down as wet deposition, which is the pollutants which are attached to anything wet, like rain or snow. Dry deposition, which is just the particles themselves, like smog and dirt and dust. Or runoff, so the herbicides and pesticides that we talk about get into our rivers and streams and take them to the Great Lakes, or it just runs into the Great Lakes directly.
So it sounds like we have a lot to be responsible for.
Everybody's got to be responsible. If everyone does a little part every day, we can really make sure to keep the Great Lakes great.
Wow. You know, I really like what you said about atmospheric deposition and the gases getting in. I think I've got a really good experiment to show that. So thank you so much for coming by.
Well, good luck.
I have a job for you.
Really? What is it?
We're going to get some gas into this liquid here.
Oh, well, what kind of liquid is this?
This is water with a little bit of base and a phenolphthalein indicator, and that's just a chemical that is pink in the presence of a base and colorless in the presence of an acid.
Okay. Well, what kind of gas are we going to put in it?
Carbon dioxide.
Oh, how? You can't be serious.
It's all you.
The things I do for science
Are deeply appreciated. Gas it up. So what you're doing here is you're introducing carbon dioxide gas from your lungs into this liquid, and some of it's dissolving and making carbonic acid. That acid reacts with the base, and the indicator goes from being pink to being colorless. Okay, I think you've got it.
Wow, I did that.
And you should be very proud. But this little chemical change shows us that some gases are perfectly capable of dissolving into liquids, which for the Great Lakes can be a problem.
Well, since the gas can get in, it can get out too, right?
Well, let's see. This is a carbonated beverage. Do you think there's gas in here? Yeah! Do you guys want to see me get all of this gas out all at once? Yeah! Okay, now listen very carefully. I'm going to open this up. That's the sound of a little bit of gas escaping. What I'm going to do now is put this little container on. It's got 3 candies in it. Those candies are kind of rough on the surface. So, when I pull this yellow pin, all 3 candies are going to drop out all at once. And let's see what happens. Ready? Now I'm going to have you guys count me down from 3. Ready? So 3,
2, 1.
What you guys saw was a lot of gas coming out of here at once. This is a carbonated beverage. It has a gas, carbon dioxide, in here. And when I put those candies in, it causes all that carbon dioxide to come out all at once in this huge fountain. This is a really narrow opening, so it makes a very tall fountain.
So the lakes are vulnerable. What's really the risk with all of this?
You know what's strange? With something as large as the Great Lakes, it can get very complicated very fast. So I invited one of our friends from the Environmental Protection Agency to come in and answer some questions for us.
Oh.
Hi, Professor Mike. How you doing?
Hi, Chris. How are you?
Doing good.
Well, my friend Lauren here, she was trying to throw away a computer monitor, and she was told not to.
Yeah.
And maybe you can help us understand why.
Well, computer monitors, like a lot of electronics, have different materials inside of them that make them work.
Okay.
So in the computer monitor, they've got lead inside the glass.
How much lead is here in this computer monitor?
Probably about 4 to 6 pounds.
4 to 6 pounds of lead are in this monitor. Wow. So where is the lead in this?
Well, the lead in the monitor is mainly here in the glass on the back. There's also some lead in the solder and maybe a few other components, but most of what we're concerned about is in that glass.
What else is in the glass we should be concerned about?
Well, there's also some barium on the front. Okay, now that is a different element that's clear that lets us see the TV picture.
I see. But there are some things in here that are not toxins that are still useful, right?
Exactly.
Like I think I see some copper.
Right.
Here.
There's copper in the yolk, and they can take that and turn that into wire again.
Okay.
Okay.
Wonderful. So if we're trying to get rid of this and just throwing it in the back alley, Is that a risk to the Great Lakes?
It could be, yeah. Yeah, things that go in the alley generally get broke.
Ah, so if it gets broken and some of this stuff is able to get out with runoff water and into the Great Lakes, then we've got a problem.
Right.
I see.
The toxins can get into the lakes.
I see. So what about computers? Can that happen with computers as well?
It can. It can. Computers also have lead in them. In the solder, in the connectors, there could be beryllium, which is we also know is a toxin. But there are also a lot of things that can be reused on the computer. There's steel, there's aluminum, there's even gold inside the computer.
I see.
Inside the processor.
Well, that's pretty valuable.
Right.
So if we want to get rid of a computer and a monitor, what's the right way to do it?
Well, going to someplace like the Goose Island Recycling Facility.
Ah, we'll have to do that.
Right, yeah. There they'll be able to take a look at it, see if they can reuse it, and see if they can even reuse just something small like the memory or maybe the hard drive.
I see.
And what they can't use, they'll recycle responsibly.
Okay. And if these metals get into the lakes, what I understand is something very small, like some of those zooplankton or phytoplankton, are able to latch onto it, and then something larger eats that, and a bigger fish eats that, a bigger fish eats that. Eventually, we're at the level of fish that we eat.
Right.
And that's called bioaccumulation. Wonderful. I wanted to make sure I understood that properly.
Yeah.
Wonderful. Okay.
That all seems really complex. It's amazing. How do you guys go about collecting this information?
Well, we have a floating laboratory called the Great Lakes Guardian.
You have a floating laboratory.
We do.
A lab on a boat.
A lab on a boat.
See, my laboratory is an 11-story building in downtown Chicago.
Yeah.
I would love to see your lab on the boat. I'd love to get a tan while I do some work.
Well, sure thing. I think we can arrange for that.
You can make that happen?
We can make it happen.
So we're on the Great Lakes Guardian, and we're coming back in from Lake Michigan. So tell us a little bit about the boat.
EPA took ownership of the vessel in the early 90s. This was originally an offshore marine supply vessel down the Gulf of Mexico. EPA got the vessel and it was retrofitted for scientific purposes.
So this is a large floating lab.
It's a 180-foot laboratory.
Hi.
Hi,
And you are?
Glenn Warren. I'm
Okay.
with EPA Great Lakes National Program Office.
And what do you do with the EPA?
I am chief scientist out here during our survey work.
And what are we looking at here?
We're looking at something called a rosette sampler. It is a water sampling device. Each of these bottles is 8 liters worth of water. We drop this into the water when we get onto one of our stations, take it all the way to just above the bottom, and then we start sampling, closing the bottles on the way up, getting water from different water layers or different depths as we come up.
How long does it take for it to go from where you drop it all the way to the bottom to bring it back?
Here on Lake Michigan, we're shallow. We'd be done doing the sampling in maybe 5 minutes.
And we're going to see you run a sample here?
Yes.
Okay.
In Lake Michigan, we would test for plankton, zooplankton, and phytoplankton, the small plants and animals that are in the
Can you tell us a
water.
little bit like the differences between zooplankton and the phytoplankton?
Phytoplankton are microscopic cells of algae.
Which is the green algae photosynthesis type of organisms.
photosynthetic.
They bloom in springtime, so we will see a lot of them out here in spring.
What is zooplankton?
Zooplankton are little microscopic animals.
Mostly here in the Great Lakes, they're small crustaceans, things called copepods and daphnia.
And you actually can measure how much you have in a certain level of water here using this rosette.
Yes, for the zooplankton, we need a net.